And so one thing that's important, in addition to being able to recognize what state of matter that a substance is in, you also need to be able to categorize matter as either being a pure substance or a mixture. And if it's a mixture, being able to determine whether it's homogeneous or heterogeneous. If it's a pure substance, you need to be able to distinguish whether or not it's an element or a compound. So elements and compounds are the two types of pure substances. An element is basically made up of one type of atom. And so an element is multiple atoms of the same type. So hydrogen, the element hydrogen, is made up of hydrogen atoms and only hydrogen atoms. Iron, the element, is only made up of iron atoms. Compounds, on the other hand, they're also pure substances, but unlike elements, compounds are made up of two or more different types of atoms. So salt, our normal table salt that we have in our kitchen, its chemical name is sodium chloride. It is composed of one sodium atom and one chlorine atom. So it is a compound because it's composed of two different types of atoms. Water, H2O, is composed of two hydrogen atoms and one oxygen atom. So that makes it a compound. And so if we were in the lab and working with the substances that we'll see in the video, these would be the safety considerations that we would want to follow. And these are general, most of them general safety considerations that you would practice in any chemistry lab, no matter what experiment that you're doing. Things such as no eating or drinking in the lab, so on and so forth, and wearing safety goggles. So now we're going to move on to data set 1. In data set 1, we're going to be analyzing states of matter, and we're going to be focused on the 3 states of matter: solid, liquids, and gases. And so in the video, you're going to see a series of vials, and of the vials that you see, you're going to identify 3 solids and write those 3 solids in the rows of that first column. And then you're going to identify 3 liquids that are contained in 3 different vials, and then do the same thing for the gases. So after you've completed your data table with 3 solids, 3 liquids, and 3 gases, then you'll go into your individual group meeting rooms and answer critical thinking questions 1, 2, and 3 with your group, and then you'll return to the general meeting room and we'll discuss the critical thinking questions, and then we'll move on to data set 2. And so I'm going to play the video. And let me know whether you can hear the volume.
I can't hear anything.
Okay. Okay, give me a second to play around with the controls here. Teams. Okay, I had this problem yesterday. I think what's going to be the best thing, I'm getting terrible feedback. I think the best thing is going to be for you to perhaps watch the videos within your groups on your own individual devices, and then go to your groups and answer the critical thinking questions. I'm trying to play the videos through my system, but the audio is just not working. Give me 1 minute to get your group channels set up, and then you would need to be logged into eLearn and go to the course content tab for week 1 to watch your videos, and then go into your individual meeting rooms. Okay, group 1, your channel should be visible. And if you go onto the left-hand side of your screen, you see the teams. You'll see activity, chat, teams, assignments. Click on teams, and then you should see the general meeting room, and then you should see group 1. So you would click on group 1 to go into that individual group meeting room to discuss the critical thinking questions with your group after you've watched the video on your own device. Say groups 2 and 3, your group meeting rooms are now available and should be visible by just clicking on Teams, and you'll see general, then group 1, group 2, group 3. So all 5 groups have now been created. And so now you can go and watch the video for data set 1, and then go into your individual meeting rooms to answer the 3 critical thinking questions. So now you should be in. Now you should be in your individual group rooms, answering the critical thinking questions, numbers 1 through 3, and then return to the general room and we can discuss them before moving on to data set 2. And so if you've finished completing your data table for data set 1, you should have also discussed the critical thinking questions numbers 1 through 3 with your group. And so, for example, for the solids that I identified, and you may have identified 3 different ones, or maybe 1 or 2 of the same ones that I identified, that's fine. But no matter which 3 solids that you identified, what proof can we write that supports the fact that we identified these 3 substances as solids? And so when we say proof, meaning that these 3 items fit the scientific definition of what a solid is. So I could say something like all 3 substances have a powder reappearance. So that's just my layman term to it and not scientific. But then to get scientific with it, they also have their own shape and volume. And that's the scientific proof that these 3 substances are solids. And so you'll go on and do the same thing for the 3 liquids that you identify. And then give me a proof that proves that these 3 substances are liquids. You can talk about things based on your appearance of them, as well as give me a scientific proof that these are liquids. And same thing for the gases. Any questions about data set 1, critical thinking questions? Now let's move on to data set 2. For data set 2, in the video that you're going to watch on your own device, you're going to notice how I handle 10 different substances. And you'll see me touching the substances and also examining them based on whether or not they're compressible, whether or not they can hold their own shape, so on and so forth. And so there are going to be 10 substances that you'll view in the data set 2 videos. The first substance is oobleck, which is just a mixture of cornstarch and water. And then copper, Baker's Joy cooking spray, corn syrup, red food dye, deodorant, helium in a balloon, hand sanitizer, marshmallow, and antiperspirant. And so you're going to fill this part of the data sheet out by describing the properties that each exhibit. Some of the properties that you can comment on are things like color, shape, volume, And when I say shape and volume, does the substance have its own shape? Does it have its own volume? Or does it take on the shape and volume of the container that it's in? And then you can also comment on some other things that I'll mention in the video, like the texture, how does it feel? Does it flow? Or does it have fluid properties? Is it compressible? Does it expand to fill the shape of the container? These are two properties of gases: compressibility and expandability. And so gases expand to fill the volume and the shape of the container that they're in. So these would be some properties that you can note as you're watching the video as I display these 10 substances. And for each of the 10 substances, you are to list some properties of each substance that you observe in the video. After that, you will answer critical thinking questions 1, 2, and 3 with your group. Now, critical thinking question 1, you're to categorize each substance as either a solid, liquid, or gas. So station 1 is going to be the oobleck. So if you think oobleck is a solid, you'll put a check mark. If you think it's a liquid as well, you put a check mark. If you also think it's a gas, you'll put a check mark. But if you don't think that it's a liquid or a gas, if you think it's just a solid, then you'll just put a single check mark in the solid category. And so that's how you'll fill out that table. You'll take each substance at each particular station, and you'll identify it as a solid, a liquid, or a gas. Or you may check more than one box. You may think that the substance has characteristics of 2 of the 3 types of states of matter. And then question 2, answer the question, did all of those 10 products fit neatly into just one category? Or were there some substances that fit into more than one category? So give an example of one that fit into more than one category and answer the question yes or no. The answer would be no if they all did not fit into one category, if there were some substances that fit into more than one. And then give them an example of one of the substances that fit into more than one category. And then 3 is a bin chart. You're going to place each of your 10 products or samples into its appropriate place on the chart. And then you're going to give this explanation for your chart. So for instance, if I feel that the antiperspirant is both a solid and a gas, then I'll put antiperspirant here. In this area. Because that's going to be overlap between solid and gas. However, if I feel that the antiperspirant is just a solid, or if I feel it's just a liquid, then I'll put it just simply in one of the categories. However, if I feel the antiperspirant is all three, a solid, a liquid, and a gas, then the antiperspirant would go here. So any of the products that you feel fit all three categories will go in here. And that's going to be the intersection between all three, solid, liquid, and gas. So any questions about how to fill out the diagram in question 3? Okay, so go ahead and go to your own device, watch the videos. There are 3 of them for data set 2. Watch all 3 videos in sequence, part A, part B, and then part C. And as you're watching your video, go ahead and answer the properties questions for each product. Then after you finish watching the video, go to your individual group room and answer critical thinking questions 1, 2, and 3. Make sure at the end, after you finish question 3's diagram, that you give an explanation for any intersections. And that means, which products did you identify as being both solid and liquid? Which did you identify, if any, as being both solid and gas? Which did you classify as being liquid and gas? And if there were some that you classified as all 3, solid, liquid, and gas, list those products there. And then not only list the products, but give me a short explanation. Why did you say that the deodorant was a solid, liquid, and gas? You got to give me at least one property of deodorant that makes it a solid, one property that makes it a liquid, one property that makes it a gas. And that's the proof that deodorant is both a solid, liquid, and gas. If you said that the Baker's Joy cooking spray was both solid, liquid, and gas, then you got to give me an explanation for that. Okay? So not just list the products that fall under the category, but give me an explanation as to why you said this product was both a liquid and a gas, or was both a solid and a liquid, so on and so forth. And then once you're done with the critical thinking questions for data set 2, you can come back to the general meeting room, especially if you have questions about data set 2. And then I'll give a brief explanation over what you need to do for data sets 3, 4, and 5. There are no videos required for data sets 3, 4, and 5, but in data set 5, you probably would want to go back and refer to data set 1 if you need to replay the video to see all the vials again for that were presented in data set 1. You're going to need those same vials to answer questions for data set 5. So you may need to jump back to data set 1 video to complete data set 5 questions. Okay? Or do we have any questions about what you're supposed to do for data set 2? Any questions? And so we've got some questions. Jesse, did you figure out what group you're in? Jesse, you are in group 2. Cameron, as far as your joining your individual group room, if you click on the Teams icon on the left-hand side of our Teams meeting room, then the general, group 1, group 2, group 3, you should see those group choices come up, and just click on your assigned group. And let's see, any other questions in the chat box? Okay, hi, Charlie. Writing on the digital lab sheet. Well, you've got two options. If you didn't print the lab data report form out before class, you can have it up on your screen to look at for reference purposes, but you can write out all your answers on notebook paper for now. But I would need you to transfer that information to the lab report form prior to submitting to the Dropbox. So you would need to, at some point today, print out your lab report form and fill it out with the information that you wrote on notebook paper, and then submit that to the Dropbox like I explained at the beginning of the lab session. I want it submitted as one single file. Either scan your completed report form and save it as a single PDF file and upload that single PDF file. If you don't have access to a scanner, use your cell phone to take pictures of each individual page of your lab report form, and then share those pictures with yourself via email or via OneDrive or Google Drive or whatever you want to use, and then go to your PC or laptop, download those pictures, copy and paste them and save them into a Word document in order, data set 1 first, then data set 2, data set 3, so on and so forth. And then save that as a single Word document file or a PDF file and upload to the Dropbox. So if you didn't print out your data sheet before lab, write on notebook paper for now, have that document form up on your screen as a reference, and then transfer the information after class, after you've had a chance to print out the report form. Now, if you have an iPad, you can, and if you have a writing software on your iPad, then you can fill it out with your iPad stylus electronically if you have that, if you have an iPad. But if you don't have an iPad, then you would need to print out your lab report forms prior to class so that you can write on them while we're doing the lab. Okay? Is that okay, Charlie? Okay, so go ahead and go to eLearn on your PC and watch the dataset 2 videos, parts A, B, and C. Fill out your dataset 2 information, go into your individual groups, and then once you're done, come back to the general room, and I'll be jumping into each individual group room to check on you to see if you have any questions. Yes, Michael, you are to be watching dataset 2, parts A, B, and C, and then answering the questions for dataset 2 with your group. Now, if one of you in your group want to share your screen with the rest of your group and you all watch the video via screen sharing, you can hover your mouse over this area of the Teams meeting screen and click on the little square with the arrow in it, and that'll be the open share tray. And then you can share your screen that's showing the video. And that way all members of your group can watch the video from one shared screen. Or you can each individually watch the video on your own device and then just have your audio on to discuss the questions with each other after you're finished watching the videos. You can hear me? Okay. So in the video that you're watching of the corn syrup, notice how it flows, but notice that it also flows much slower than water would. So the corn syrup is more viscous. It has a higher viscosity than water, but it still has some properties of a liquid, even though it's viscous. It has its own volume, but it doesn't have its own shape. It takes on the shape of its container. Now, the red food coloring, it is less viscous than the corn syrup. It flows much like water does. It flows very fast. Whereas when we poured the corn syrup, it flowed very slowly. But look at how fast the red food coloring flows and how fast it disperses itself throughout the sample of water. And so would you say that the corn syrup and the red food coloring are strictly liquids? Or would you put them into another category as well? What about the Baker's Joy? We sprayed some of it on the table, but we noticed that there's still some there. The texture of it felt grainy. That's the flour that's in the Baker's Joy. It also looks wet on the table, giving it characteristics of a liquid. But if you also notice on the table that some of that Baker's Joy has disappeared. So that makes me think that some of it in time may have evaporated. So once inside the can, it's under pressure and there's no evaporation. But once you put it under the normal atmospheric pressure conditions of the room and the temperature of the room in combination with atmospheric pressure, then some of the components in that Baker's Joy has disappeared because there's not as much of it there on the table as it was when we initially sprayed it. So we can assume that some of it has evaporated. And now the balloon has the helium inside of the balloon. And so think about the helium filling the balloon. Does that give helium the properties of a solid, liquid, or a gas, or does it fall into more than one category? Now I'm adding some of the deodorant to the table. The deodorant has a smooth, powdery feel. It's white in color, so it has a definite texture. And so the stick of the deodorant is showing a definite shape, just like the container that the deodorant's in. But when you rub some of the deodorant out, it doesn't have that same shape that it has when it's in the bottle. So think about the deodorant. Is it a solid, liquid, or gas? We want to take note of the table to see if any of the deodorant evaporates over time. And now looking at the hand sanitizer, it has some liquid properties. It's taking on the shape of the container. But there's blue dots, circular dots inside of that hand sanitizer. So those circular dots have its own circular shape. So that's giving you some properties of a solid that's mixed in with the hand sanitizer, which has some liquid properties because it's taking on the shape of the container. And then we probably want to put some of that hand sanitizer on the desk as well, just to see if it evaporates after some time has expired. So therefore, we're going to have to take all those things in consideration in making a decision about the hand sanitizer. Is it a solid? Is it a liquid? Is it a gas? Is it 2 out of 3? Is it 3 out of 3? So we'll take note of the table and see how the hand sanitizer appears after some time has expired to see if any of it evaporates. And if any of it evaporates, that means that at room temperature, there are some components in that hand sanitizer, in that deodorant, in that Baker's Joy, that at room temperature and under normal atmospheric pressure, those substances convert to gas because they evaporate. That's what evaporation is, the conversion of a substance from a liquid to a gas. So therefore, there had to have been some liquid components in the substance at first, but then when taking it out of a pressurized can or subjecting it to room temperature and not under pressure of the container, if those substances now under room temperature and normal pressure evaporate, that means some of the liquid components in that substance have been converted to a gas. So what that means is that there are some type of components that make up that product that are volatile, meaning that they evaporate very easily, especially at room temperature. So in addition to the hand sanitizer, we also put some of the antiperspirant on the desk. The antiperspirant looks wet, so that gives it a liquid property. But we also want to see if any of that antiperspirant evaporates over time, giving it some gas-like properties. And then finally, looking at the white marshmallow that definitely has its own cylindrical shape, giving it properties of a solid, but also analyze the mushroom and see if you think it has any other liquid or gas properties. If not, then you will put the marshmallow solely in the solid category. And then again, take note of the products that we put on the desk to see if in time, if they're evaporating. So let's take a look at the hand sanitizer. And we definitely noticed that the same amount that the amount that we initially had is not the same amount that we have now. So some of it has evaporated. And take a look at the antiperspirant as well. And then what about the Baker's Joy and the Secret deodorant? Do you notice any of it evaporating over time? If so, that means they contain volatile components, meaning that they convert easily from a liquid to a gas at room temperature. Most hand sanitizers contain alcohols, and alcohols are volatile liquids, meaning at room temperature they will evaporate. So if you have some alcohol in your medicine cabinet at home, if you leave the top off of that alcohol and leave it in the room over several days, or it may even take a week or so, if you pour out a small amount of it into a little cup, over time, that alcohol is going to evaporate. It may, depending on how much of it you have, it may take days, it may take a couple of weeks, but in time, that alcohol will evaporate. So noticing the evaporation in the hand sanitizer, antiperspirant, Baker's Joy, there must be some volatile components like alcohols in those substances that causes it to evaporate at room temperature. So now that you've seen all 10 substances, you want to categorize them as solid, liquid, or gas, or determine if they fall into more than one category. So fill out your data sheet. First, the data table, putting check marks next to each station, writing down what product is in that station. So station 1 would be the oobleck, station 2 would be the copper, so on and so forth. And then put in a check mark under in the row where the solid column, if you feel the oobleck is a solid. If you feel the oobleck is also a liquid, put a check mark in the liquid column, so on and so forth. So the first part of the data set 2 is we need to write down properties for each product that we saw. So this is an example of what you would want to write, like for oobleck. You can say it's white. It looked like bread dough. That was my observation. The texture, it was smooth, but it also felt a little rubbery, kind of like rubber. Does it have its own shape? Well, I was able to roll it up into a ball, but soon as I let go of the pressure that I was putting on that oobleck to shape it into a ball, it started to fall out of that ball-like shape and start to flow again. So yes, it does flow. And therefore, when the oobleck was in my little glass bowl, it was taking on the shape of the glass bowl. So I would say no, it didn't have its own volume. It was taking on the more of yes, it does have its own volume. But as far as shape, it does have its own shape when applying pressure from my hand. But when I'm not applying pressure on that oobleck, then it flows just like a liquid. It had a texture that's smooth and rubbery like rubber, so reminding me of a solid. And then moving on to station 2, copper. You can say it had an orange-brown color. It was shaped like ribbons or strings. It was easily shaped and bent. And also has its own volume. So these are some examples of how you can describe the properties of each of the substances that you observed. And so therefore, based on my description of the properties of oobleck, and of copper, I would say copper is just a solid, but I would say oobleck is a solid and a liquid. And then I can go ahead and answer question 2, because my very first product did not fit neatly into one category. And then question 3, so now I can go ahead and put oobleck here in this intersection of solid and liquid. But copper, I'm going to put exclusively in the solid circle. So as you fill out the properties for each substance, and so here are some of my observations of the Baker's Joy. It looked white, foamy when you sprayed it out of the can. It felt gritty because of the flour component. It sprayed out of a can, so therefore it had some type of flow to it. But some of it did evaporate as it sat on the table over time, but it did look wet on the table. So based on my observations of the Baker's Joy, can someone tell me where we should put the Baker's Joy? What boxes should we check?
My group put all three for that one
Okay.
because of the flour, because of it being like wet,
Mm-hmm.
and because it was in an aerosol can.
Absolutely. Great observations. Does anyone disagree? So therefore, for the Baker's Joy, on the diagram, where should it go?
In the middle of all of them.
It should go in the middle. So it should be intersecting all three. Anyone disagree? So now in our explanation for intersections, we put the Baker's Joy. In our explanation, it's an aerosol, making it a gas. Gritty texture because of the flour. That makes it a solid. And then the wet appearance. That makes it have liquid properties. So that's telling us that Baker's Joy got a whole lot of different types of stuff in it. And all these different components, some of them have solid properties, some of the components have liquid properties, and some of the components are volatile and compressible like a gas. Because if it wasn't compressible, you couldn't put it in the aerosol can and keep it under pressure. So therefore, the Baker's Joy is exhibiting all three states. And now we put the oobleck. Does anyone disagree with my analysis of the oobleck? Did everyone else put the oobleck in the solid and liquid category?
Yes.
The texture was very rubbery. So that gives us characteristics of a solid. I was able to shape it into a ball. Those are all solid characteristics, but it flowed like a liquid. Okay. What about the corn syrup at station 4? It was very thick or viscous like motor oil or molasses, but it did flow. And I put some of it in a beaker, and I could read the little markings on the beaker and determine exactly how much, as far as volume, of that syrup I had poured in the beaker. So it did have its own volume. But it took on the shape of the jar or the bottle that the corn syrup was in. And then when I poured it in the beaker, it took on the shape of the beaker. So it took on the shape of the container. So where are we going to put the syrup?
Liquids.
So the syrup then will go strictly in the liquid circle. What about the red food dye? It flows. It disperses easily in water. So it's miscible in water. We'll learn about miscibility of liquids in a later lab. So where are we going to put the red food dye? I would put it strictly in the liquid category. Does anyone disagree?
Nope.
Okay. So we've done the first 5 together. Are there any of these that we're unsure of that we want to debate? So where did we put the deodorant? What boxes did you check for deodorants?
My group just put solid.
Any other
Could it be
opinions?
all 3?
You picked all 3?
Yes.
So justify the liquid and gas choices for me.
Well, gas, because when it's on the table, it began to evaporate a little bit. But then liquid, because when it was rubbed out, it had more of a wet substance.
Okay. And Jesse wants to talk about the antiperspirant and hand sanitizer. I'm inclined to agree with you on the gas part. And then I would even say liquid possibly, because when you rub it on, it does feel a nice, it doesn't feel hard or solid or grainy, or it doesn't have much of a texture like you would expect for most solids. It feels very, very more like a wet feel, or not so much of a grainy, heavy texture feel. So I would definitely feel comfortable putting it in 2 categories, the solid gas, because there are some components in the deodorant that do vaporize at room temperature. So I would give you credit if you put it just in the solid gas area, or if you put it in all 3. Or if you didn't notice the evaporation, if you just put it in the solid category, I won't take off for that either. The deodorant was a tough one. The antiperspirant and the hand sanitizer that Jesse wants to talk about, those are a little tricky too. Okay, so where do we put the hand sanitizer? Anyone want to share?
We put it in all three because of the blue round beads.
I agree. You have the little blue moisturizer beads in it, and then when we put it on the table, it looked wet, but over time we saw it disappear. So some of those components were very volatile and they converted to a gas. So we can put the hand sanitizer with the Baker's Joy.
Is evaporation an automatic characteristic of something that's gaseous?
Well, liquids will become volatile at a certain temperature and pressure. So what we observed that there are components in the hand sanitizer and in the Baker's Joy that are volatile, meaning that they are liquid under the initial conditions. But when we take them out of the container, that means they're no longer under pressure. When you spray the Baker's Joy out of that aerosol can, it's no longer under pressure. And then you're also subjecting it to normal atmospheric pressure. And so therefore, that's going to cause some of those components to convert from a liquid to a gas. So when you spray that Baker's Joy out of the can, when it comes out of the can, it's a liquid. But as it enters the room temperature conditions and normal atmospheric pressure conditions, some of those components that are more volatile, they will convert to a gas. So you can consider the Baker's Joy and the hand sanitizer as having gas-like properties because they're easily converted to a vapor. And then the liquid characteristics of the spray, because it flows easily out of the nozzle of the aerosol can. And when we sprayed it on the table, it had that wet appearance. So the components do not vaporize and turn into a gas immediately. It takes time. So initially, when that Baker's Joy came out of the can, you had the grainy flour component, the solid, and you had the liquid, hence the wet appearance on the table. But after time, that wet appearance started to disappear. But you still had the grainy flour component on the desk. So the solid flour remained, but a lot of the liquid components converted to gas. What about the helium? That helium filled the volume of the balloon. The helium took on the shape of the balloon. So would you say the helium is strictly a gas?
Yes.
What about the antiperspirant and marshmallow? Do they fit into just one category?
I think so.
I would put the marshmallow as a solid.
And I was
So-
thinking a liquid for the antiperspirant.
Did any of it evaporate?
Yes, it did. The antiperspirant evaporated a little.
Yes. So there are some components in that antiperspirant that convert it into a gas. So we'll put the marshmallow in the solid, put the helium in the gas, and put the antiperspirant in liquid and gas. So make sure that you filled out your properties. Give me at least 2 or 3 properties for each of your substances. Put in your check marks in the critical thinking question 1. Answer the question. We already answered that one. No, all of them didn't fit neatly into one category. And I've given one example of one that didn't. Oobleck. If you want to use the oobleck, you can, or you can use the antiperspirant or the Baker's Joy. And then give me a description of what properties that product have. Do they have both solid and liquid like oobleck, or did they have all 3 like the Baker's Joy, so on and so forth. And then your Venn diagram. And then all those that had intersections, you need to put in this table, like the oobleck, I put there in the solid and liquid, and I gave some justifications why it should be there. Same thing with the Baker's Joy. I justified why it fits all 3. So those are the ones: oobleck, Baker's Joy, hand sanitizer, antiperspirant, and deodorant that are in these intersections. The others fall neatly into one category.
Can you explain one more time why deodorant would also be a gas?
If some of it, not as much as the hand sanitizer and Baker's Joy, but a little bit of the deodorant did evaporate over time. So therefore, there are some components in the deodorant that did evaporate. And so when you have a solid go directly to a gas, that's called sublimation. So a little bit of that deodorant evaporating and turning into a gas gives it some gas, the components, some gas-like properties. But if you feel that it should go exclusively in the solid category, I'm not going to count that against you. So the solids could be, the deodorant could either be exclusively in the solid or in the solid gas intersection. I'll accept either answer, okay?
And then one more question about that. So when it comes to the evaporation in determining its state, is the time component of how long it takes to evaporate more important, or just the fact that it does evaporate at?
Yeah, the fact that it does evaporate in time. And depending on how the concentration of the volatile components in that substance, that's going to determine how much time it takes for you to notice evaporation. If, like with the hand sanitizer, you've got lots of alcohol in hand sanitizer, and alcohols evaporate very quickly. So it didn't take very long for you to notice the hand sanitizer disappearing or the Baker's Joy disappearing, because they have more volatile components in them than deodorant has. So that's why it'll take longer for you to notice the deodorant evaporating versus some of the others that fall into that gas intersection component. Okay, so that's why with the deodorant, I'll accept either solid only or solid gas. Because we know, like, if we have a deodorant like the Secret that's white in color and we put it on, and after a while, when you initially put it on, you can touch underneath your arms and you can feel it. You can feel the grittiness of it. But then after time, as the day goes on, you can't feel it anymore because of that evaporation effect. A lot of it has evaporated and penetrated into your skin. A lot of it has evaporated into the atmosphere.
So would you say something like water has similar qualities? At
room temperature, water is just a liquid. So we can set we could sit the water in the room, and it would take a really, 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 really long time for water just at 20 degrees Celsius. Water does not boil until it's at 100 degrees Celsius. So water is going to remain a liquid at room temperature. But if you put it on a stove, of course, it's going, if you reach 100 degrees, it's going to evaporate, it's going to boil. So therefore, Baker's Joy, you don't need to boil it for it to start evaporating, because it's got components in it that are much more volatile or easily evaporated than versus something like water. Now, the Baker's Joy, the hand sanitizer, they've got water as one of their components. That's what makes it liquidy. But they've also got alcohols and other organic chemical compounds in them that do evaporate very easily. Any other questions? So now for data set 3, there's no video required to complete data set 3. You need to use this periodic table that's provided for you to answer the questions. So we said that pure substances can be subcategorized to be either elements or compounds. The periodic table contains all the known elements. So the periodic table, does it represent pure substances or mixtures?
Pure substances.
Very good. Does the periodic table represent elements or compounds?
Elements.
Okay. So how are substances grouped into metals versus nonmetals versus metalloids on the periodic table?
Wasn't it the location?
Mm-hmm. Very good. All of these guys are metals. All of these guys are nonmetals that I'm drawing in the green. Now those that I'm circling with the hot pink, these are the metalloids. And you can
And
say they kind of sit on the stair step here. Go ahead.
and then hydrogen still counts. It still counts as a nonmetal.
You are very correct. And so to answer that question, now that we've kind of categorized the periodic table, where are the metals? The metals are on the major left-hand side, and also these guys here on the bottom. Those are also metals. Those are called your lanthanides and actinides metals. This first column of metals here, lithium, sodium, K, potassium, rubidium, so on and so forth, those are your alkali metals in the first column, excluding hydrogen. And then the second column, beryllium, magnesium, calcium, so on and so forth, those are your alkaline earth metals. Then here, right in the middle, these are your transition metals. And then, of course, here on the bottom are your actinides and lactonide metals. And then the nonmetals, this very last column, these are your noble gases. And then the next to the last column with fluorine and chlorine, these are your halogens. So those are two special names for group 7 and group 8 of the nonmetal section of the periodic table. So to answer that question, you can just give a brief sentence describing that. You can say the metals are on the left-hand side and the bottom of the periodic table. The nonmetals are found on the farthest right side of the periodic table. And the metalloids are along the stair step in between the two. Metalloids have both metal and nonmetal characteristics. The most popular metalloid is silicon. And because of its metal and nonmetal characteristics, silicon is very popular in electronics because with metalloids, you can control the electrical conductivity and the flow of electrical current can be controlled better if your electronics are made of metalloids instead of metals like they were in the earlier days of electronics. So silicon has revolutionized the electronics and computing industry because of the fact that it's a metalloid. And well, you say, well, boron's a metalloid, and so is arsenic and tellurium. Why aren't they used a lot in electronics and computer products and things? Well, silicon is very abundant in the earth. Sand, the major component of sand is silicon. So we've got a lot of silicon on the planet. That's why it's so attractive to be used in electronics, because we've just simply got a lot of it. Any questions about data set 3, critical thinking questions? So for data set 4, you're focusing on states of matter, classification of matter, and also chemical formulas of matter. We'll introduce chemical formulas. We'll be talking about chemical formulas in lecture toward the end of chapter 1 if you haven't gotten to it yet in your lecture. And so, how does the formula of an element differ from that of a compound? Well, we know that an element is made up only of a single type of atom. However, a compound is made up of 2 or more types of atoms. So therefore, if I'm talking about a single type of element, like for example, iron. Iron's formula is Fe. But if I'm talking about a compound, like iron oxide, it's made up of two different types of atoms, iron and oxygen. So the formula of an element just has the symbol for that element, that single element. But the formula of a compound has the symbols for all of the different types of elements that make up that compound. Iron oxide being an example that contains both iron and oxygen. 2 atoms of iron, 3 atoms of oxygen. Another example is water, H2O. Water would be a compound made up of 2 elements, hydrogen and oxygen. 2 atoms of hydrogen, 1 atom of oxygen. But oxygen itself is an element because it contains only oxygen atoms. And oxygen exists in the air as O2. 2 oxygen atoms bonded together. But because they're the same type of element, oxygen, this is considered an element. In some textbooks, you may see it referred to as a molecular element or a molecule. But oxygen combined with iron, that's a compound. Any questions about number 1? And we've pretty much answered question 2. An element is going to only contain one type of atom or one type of element. So elements contain only one type of atom, whereas compounds contain more than one type of atom. So now, with question 3, you are here on the matter classification chart. Matter can either be a mixture or a pure substance. Pure substances can be further classified as elements or compounds. So how does a pure substance differ from a mixture?
Pure substances, they can be broken down by physical means like mixtures can. It requires a chemical change.
Very good. So pure substance can only be broken down simpler into simpler substances by chemical means. Whereas a mixture can be broken down into simpler substances by physical methods. So if I have a formula for water, H2O, And I put the little lowercase l there. And then here for water, if I put G, and then here for water, I put S, what do these little labels mean? Those are the states of matter: liquid, gas, solid. So this is ice, water vapor, and then liquid water. But what about this one? NaCl, and then with an AQ symbol. What does that label mean?
Is it aqueous?
Very good. What does that mean?
I'm not sure. Maybe like fluid or liquid like?
Dissolved in water. So if I have some salt, sodium chloride, that's your normal table salt that you have in your kitchen. And that's a solid. And I've got a glass of liquid water. And I'm going to put the salt in the water, and I'm going to stir. And now I have a saltwater solution that I can call an aqueous solution of sodium chloride, because that sodium chloride is now dissolved in the water. So aqueous means that the substance is dissolved in water and you have an aqueous solution. What's another name for a solution?
Mixture?
Very good. What type of mixture? Homogeneous. A solution is always going to be a homogeneous mixture, meaning that it's uniform in composition throughout. When I stir the salt into the water, I've got the same concentration of salt in my entire glass of water. There's not more salt at the bottom of the glass than there is at the top of the glass. There's an evenly distributed amount of salt throughout that glass of water. That's what it means by being a homogeneous mixture. But if I have a box of Fruit Loops, that box of Fruit Loops is a heterogeneous mixture, because I may have more yellow Fruit Loops at the top of the box, but very little yellow Fruit Loops at the bottom of the box. The bottom of the box may be dominated by red Fruit Loops. So therefore, the Fruit Loops, or a bowl of soup, or a box of Raisin Bran, you don't have the same number of Raisin Brans at number of raisins at the top of the Raisin Bran box and then at the bottom, or something of that nature. So those all represent heterogeneous mixtures. But a solution of salt water that has been stirred appropriately will represent a homogeneous mixture. Like milk, when milk comes out of the cow, it's a heterogeneous mixture. Then they put it through a homogenizer or homogenization machine to blend in all the fat and the proteins and all the other components that are in milk so that it's uniform throughout. And what you buy in your grocery store is a homogenized container of milk. So any questions about number 4, what these labels mean? So question 5, what's happening there?
Condensation.
Going from liquid to gas.
Mm-hmm.
Water evaporated.
Right, that's vaporization. Condensation would be the opposite. Going from a gas to a liquid, that's condensation. But going from a liquid to a gas is vaporization.
I
Or
get the two mixed
evaporation.
up so much.
So you can say vaporization or you can say evaporation. Either one is fine. So is vaporization a chemical or a physical process? Taking liquid water and converting it into gaseous water. Physical or chemical change?
Physical.
Very good. Why?
Because it's still water. It didn't
It's
become a different substance.
very good. Very simple, short answer to that question. Because it's still water. It's still H2O. It's just in a different state. Any questions about data set 4? And so we have our classification of matter flow chart shown here. So use the flow chart. And you're also going to have to remember the video for data set 1, those vials that we looked at, you know, the vial of sulfur, the vial of sodium chloride, the vial of sulfur plus sodium chloride, the vial of iron, the vial of the liquid water, the salt water, so on and so forth. Remember those vials because we're going to also have to consider those vials that we viewed in the data set 1 video to answer these questions as well as the flow chart here. And so when we looking back on the matter listed in data set 4 on the previous page, identify each type of matter as either a pure substance or a mixture. And so if we look at water, and just looking at the conversion of water from a liquid to a gas, would you consider water a pure substance or a mixture?
A pure substance.
And so if we remember the vials that we saw in data set 1, the NaCl, that's the sodium chloride. Then we also had iron. And there was one more substance. I erased that. I can't remember what the other one was for the solids. But then we also had liquid water.
It was sulfur.
Okay, so sulfur, sulfur plus NaCl, these were our solids. Our liquids were water, salt water, and ethanol. Then our gases were CO2, oxygen, and air. Okay. And so this is how we can answer question 1. So our gases, the first 2 were pure substances, but the air is a mixture of nitrogen, oxygen, and CO2. The liquids the water is a pure substance, the ethanol is a pure substance, but the salt water is a mixture. Then you can do the same thing for the solids. They're all pure substances except for the sulfur NaCl combination. That one is a mixture.
Can I ask a quick question?
Yes.
So for number 1, when it says the matter listed in data set 4, I'm seeing copper, helium, water, table salt, salt water, coffee, brass, muddy water. Are those the
right?
those...
I was looking at data set 1. Thank you for that. So for data set 4, okay, you're correct. Copper, helium, water, table salt. Yes, these are the substances that you should classify.
So the exact same process, just
Right.
okay.
Right.
Thank you.
So for data set 4, we talked about that. So data set 5, looking back at those substances, identify each as either a pure substance or a mixture. So the copper is pure, helium is pure, water is pure, table salt is pure, salt water would be a mixture. And then think about your coffee, what all you put into your coffee. Is it pure, is it a mixture? And then brass is an alloy, meaning it contains 2 or more different types of metals. And then muddy water, we know it contains mud and water. And so the pure substances, I'm just going to use a couple of examples. Like the helium is an element, but it's a pure substance. But also in data set 4, table salt is a pure substance. But it's a compound. But one of the mixtures in data set 4, like the salt water, so for the mixtures, you got to have a plus sign between each component. But with the pure substances, if it's an element, then it's going to have, the formula is going to be the symbol of the element as it exists in the periodic table. But for a compound, you're going to have 2 or more different types of atoms in the formula. With an element, it's just that one type of atom. With a mixture can be 2 or more compounds mixed together, and you'll write the formulas for each compound and put a plus sign between the 2. So that's how the formulas differ for a mixture And for a pure substance, it could either be an element or a compound, and the formulas for elements and compounds differ as well.
So I have this lab printed out, and even I pulled it up on that chart that you just said of all those. They're not on my printed sheet or the one that's signed.
But there are two documents.
I have everything but that part.
Okay.
Would I need to look somewhere else for that, or should it have already been with?
Hold on a minute. I'm gonna have to log back in to eLearn. I was logged in earlier in the course, earlier in the class meeting, but I think I've been logged off. Yes, I need to re-log in. And I've got so many windows open that I'm confused. Where are you, TigerWeb? TigerWeb, there you are. So you're saying you're not seeing the sheet that I'm showing on my screen, that I was showing on my screen? Go to course content. Oh. Chose the wrong thing. So for this week, there's the report sheet. Here's the actual full document. So you're saying you didn't find this? So this has the data sheet and the instructions. So I had both documents there. This is all I want you to turn in to the Dropbox for a grade, is the report sheet. But you also need to download each week the full document that gives you all the instructions for the lab. So this is the procedure and data sheet.
Okay, yeah, I have that part, just not the second data sheet for listing of what we're looking at right this second.
I'm not following you. I'm not understanding what you're missing, what you don't have.
So data sheet number 4, where it says state classes and chemical formulas of matter. I have that. I just don't have where you were talking about the copper and
This here?
Yes, I don't have that right there.
Really?
It's not anywhere on my printed or on the part where I go to see to look at it.
Is that the case for anyone else?
It's on the lab report, but it's not in the regular classifying matter worksheets.
Okay. I'm in eLearn.
If you go to the classifying matter, it's in that one.
Yes, this is
not in the lab report one.
Right. This is the full lab document. It has all the instructions in it. You need to print each document that I post each week. You need to download and print both documents, because see, I don't want you to turn all this into the Dropbox. I don't need you to turn in all the instructions, to me. All I want you to turn into me for a grade is the report sheet that has all the answers to all the questions and has all the data tables that I'm going to be grading. This is all I'm going to grade, is the lab report sheet. I don't need you to turn in this entire full document, but you need to have this entire full document during lab class time so that you can read the instructions and get all of the important information that you need to answer the questions, like this information for data set 4. You needed this document in order to understand, well, what are they talking about? The substances in data set 4. I don't see anything on my report form. Well, they're not on the report form. They're on the full document. So you need to, I'm going to try to do that each week, because it just makes it easier as far as turning in your report, to have a separate report document to fill out and turn in for a grade. And it makes it also easier for the instructors when we're grading, that we're not going through pages and pages of stuff that we don't even need to grade anyway, such as instructions and procedures and things of that nature. We don't need to be sifting through those in the grading process. So that's why there were 2 documents uploaded for you. One was the full document with instructions and everything, and the other is just the lab report form that you need to fill out and submit to the Dropbox for a grade. Does that make sense now? I'll try to carry on that same structure throughout the semester. Each week there will be 2 documents, and you need to print out both to be ready for class. Both the full document with all the instructions and procedural steps, but then also just that report form. And that's what you're going to actually turn in for a grade. And so I think we got through question 2. And so for question 2, you just basically distinguish how pure substances and mixtures are different from each other based on chemical formulas. We talked about that one. And then looking back at the vials, this is what I was doing initially. The vials are from the data set 1 that we had on the desk in the video for data set 1. And this is where the sulfur and the sulfur plus NaCl, those vials, and then the vial of air and CO2 and so on and so forth. So those are the vials that they are referring to in questions 3, 4, 5, 6, and 7. And so if we really quickly just to make sure that we've got all of the solids. I know all of the 3 liquids and the 3 gases. So the solids were iron. There were 5 of them: iron, sulfur, sulfur plus sodium chloride, and sucrose. That was the 3rd one. So I'm going to list all of the substances from data set 1. We had sulfur. You had sulfur plus sodium chloride. You had sodium chloride. You had sucrose and iron. We also had CO2, oxygen, and air. We had water, salt water, and ethanol. So 11 total substances from that data set 1. Now we need to categorize them as pure elements, pure compounds. These are all under the same classification as pure substances. The pure substance can either be a pure element or a pure compound. And then mixtures. Mixtures can either be homogeneous or heterogeneous. Okay, so where do we put sulfur?
Pure elements.
Sulfur plus NaCl.
Pure compound? Or is it a homogeneous mixture?
Very good. It's 2 things. Remember, when you see a plus sign, you know it's a mixture. So heterogeneous, I agree. Does everyone agree that it's heterogeneous?
Yes.
We may have had a lot of sulfur at the top, but a lot of sodium chloride in that vial at the bottom. So those two components mixed together were in a heterogeneous way. We didn't have the same amount of sulfur in every part of the vial. What about the sodium chloride?
Compound.
What about where are we putting the sucrose?
Pure compound.
Pure.
Okay. And the iron,
Pure element.
carbon dioxide, CO2.
Say pure compound.
Very good. It's made of two different elements, right? Two different types of atoms, carbon and oxygen. So that makes it a compound. What about oxygen, O2?
Pure element.
Very good. Water,
Pure compound.
salt water,
Heterogeneous mixture.
so the salt plus water, the salt water. Was it uniform throughout? Could you see some salt sitting on the bottom of the vial, or was it all mixed in? Was that salt completely dissolved?
Probably.
Mm-hmm.
I'd
So
say
we'll call that a homogeneous mixture. Because that salt was completely dissolved in the water. It was all mixed in very well. There wasn't any salt sitting at the bottom of the vial. And finally, ethanol. That's the formula for ethanol.
Holy cow.
C2H5O. It's made of 2 carbon atoms, 5 hydrogen atoms, and 1 oxygen atom.
Pure compound.
Very good. So just by looking at the vials, talk about how you can distinguish what category they belong in just by looking at them. And then again, just by looking at them, how can you tell a homogeneous mixture from a pure liquid? So how can you tell the salt water?
It's kind of foggy.
So appearance, so cloudy versus uncloudy.
Yeah.
Okay. So how could we distinguish between a mixture like the salt solution and the water without salt by using a simple experiment? What kind of experiment could you do? What if the salt was mixed into the water so well that it wasn't cloudy? What if the salt water sample was just as clear as the pure water? What kind of experiment could you do?
Taste.
No physical change.
So do a physical process like what?
Like
Boiling it.
eating it. Yeah.
Boiling, filtering. What about filtering? If we use some filter paper, if there was salt in the water, do you think the salt would flow through the filter paper, or would the salt get trapped in the filter paper?
You'd get trapped if the pores were small
Right.
enough.
And the water would pass on through. So you could separate the salt from the water by filtering, if there is salt in the water. Very good. So we would want to use some physical processes to determine whether or not we're dealing with a mixture. So physical processes will separate the components of a mixture. So if you indeed have a mixture of salt and water, you can either boil the substance and all the water will evaporate and you'll have the salt left in your container, or you can filter. The salt will get trapped in the filter paper, the water will pass right on through. But then if it's just pure water, then you're not going to notice any salt being trapped in the filter paper. And when you boil, your container would just be boiled dry. There won't be any salt left over in the container. So now that we've gone through the lab, write me a conclusion statement about matter. Just a nice summary of everything that we've talked about. You say matter can be classified as blah, blah, and then give me some descriptions of, what makes a pure substance different than a mixture. And then how can you distinguish between a heterogeneous and a homogeneous mixture? And if it's a pure substance, how's an element different from a compound? They're both pure substances, but what makes them different? So just write me a nice little paragraph, no more than 3 or 4 sentences, summarizing what you've learned today. Okay. So the way we've set up our labs this semester for you to turn in your lab report is that you don't have to turn it in, like it's not due right now, this minute that we're getting ready to leave lab. You'll have until 11:59 p.m. tonight to get it submitted to the Dropbox. And if you're going to be late, if you need until Sunday to get it up in the Dropbox, just email me and let me know. The first couple of weeks, I'm very lenient. I know we're all getting back into the groove of school. So am I. So if you can't get it uploaded tonight by 11:59 p.m., just send me an email and say I need another day or two. And I'll just say, okay. So I'll be very lenient with the first one and next week as well. If you need the entire weekend to get it finished, you may need to work out your printing and scanning and how are you going to be doing the compiling everything to submit. So if you need a couple of extra days to get everything finished and submit it, I'll be very lenient this week. So everyone okay with how to find the Dropbox? Go to Activities, Dropbox, and then click on Classifying Matter, and it'll give you the option to upload. And as you can see, some other students from some other sections have already uploaded theirs. Another way is just go to the course content, go to week 1, scroll down, and there's the Dropbox again. So there are 2 different places in eLearn where you can find the Dropboxes for the lab. Under the course content for that week, I'll always put a Dropbox there that I'll always copy the link and put it there, but then you can always go directly to Activities and Dropbox. Any other questions before we end class for today?
No, ma'am.
I have a question.
Yes, ma'am.
So my Teams crashed when you were explaining what we should do if we don't have a scanner. Can you repeat that for me, please? I meant to ask you earlier, but
Absolutely. So if you don't have a scanner and you've got your lab report form for this week, you got it printed out, you've got it all filled out with all of your questions answered, all your data tables filled, and now you're ready to submit, but you don't have a scanner. What you'll do is take each page and take a picture of each page with your cell phone. And you'll share each picture file with yourself, email it to yourself. So what you'll have emailed to you is a certain number of picture files. Then what you need to do is go onto your laptop and then download each of those picture files, copy them, and paste them into a Word document. And make sure you copy and paste them in order, like data set 1, then data set 2, and do 1 picture per page. And upload those different picture pages in order into your Word document. And then save that Word document as either a .doc or a .pdf file. And then upload that saved file to the Dropbox.
Okay, thank you.
That way, you're only uploading 1 single file to the Dropbox. And that is what I prefer, rather than you uploading 10 different picture files. Any other questions?
Will this recording be posted later?
Yes, I am recording you and I will post it. It takes about 30 minutes after we end the class for it to process. So once it's processed, I'll get an email notification that the video is ready. And then let me pick a set place. What I'll do, where it says videos for the classifying matter lab, I'll add the video for the class in this same area.
Okay, thank you.
You're welcome. Great question. Thank you for reminding me of that. Any other questions? If not, have a great weekend. Get your completed lab report form submitted by 11:59 p.m. tonight. If you need a little bit more time through the weekend to do it, please do so. I'll be very lenient. There won't be any late penalty if you turn it in a little bit later for this first time.
Thank you.
Thank you. And I hope you guys enjoyed the lab. And I'll see you in class if you have me for class, or I'll see you next Friday.